the head. Isn't she sweet? She has antennae. They're called antennae because it's a pair. When you're talking about one, it's an antenna. They have two eyes. They have compound eyes and they have ocelli. They have mandibles and they have a proboscis. And I'm going to tell you about those. This is the antennae or the antenna. You see it's got a segmented part. Can you guys see? See the segmented part? That's called a flagellum. The drones actually have one more than the females. Then the part that bends over there, it's a pedicel. That's their elbow. And then that solid piece is a scape. Now it connects to the brain through a double nerve that deciphers all the information. It sits in these sockets on the top of their head and it makes them free moving. So they can move independent. And they have a 90-degree bend. So they have a greater feel for what's happening. Moreover, like a butterfly is just as straight out. They don't have as great in touch with what's happening. These guys can independently move them. They can taste with them. They can determine texture, odor, taste, chemicals. And it's really sensitive. It helps with their flight speed also. So if you're getting close to something, you might want to slow down so you don't just smack into it. So it helps them know that. That's what that is. They have one on each side. And these are their compound eyes. This is the big ones. Yes, sir?
If they lose an antenna, do they die?
You know, I don't know. If a queen loses an antenna, they will kill her.
Oh,
Any
really?
imperfections on that queen, they see that she is not 100%, and they will replace her.
Oh, wow.
If you are careless, pulling out the frames to inspect, you bend her antenna, you break a leg, you crimp her wing, whatever you should do, you'll see some people take their queens and they advocate, let's cut one wing so she doesn't fly off. Well, they perceive that as an imperfection.
Yeah.
You've killed your queen.
Oh, wow.
So, yeah.
You
So,
perfect.
yep, you got to be top girl. But so these compound eyes, they have lots and lots of little lenses. They have thousands and thousands of these little lenses. This is a close-up here. Every one of these lenses is called a facet. And there's these little hairs that grow between each and every one of them. Now these compound eyes, they see the polarized light from the sun. And it helps them to navigate on cloudy days because they don't see like we see. They're very sensitive to light and to motion, and they see color. So you'll hear a lot of us because they can lock onto something fast, a predator, a robber fly, a bird, something. They can lock onto really fast movement. So that's why you'll hear us tell you always, slow down. Don't get in a rush because you don't want to hurt your queen, but don't get in a rush and slow down. Be calm when you're working your beast. Don't swat, don't run. Be very, very calm because they'll lock onto you and they might perceive you as a threat. And you don't want to trip that alarm that says we need to defend our hive. So you want to go slow. But this over here is kind of just an illustration of a cutaway. You can see how all those lenses all have a little nerve that comes down and they connect. So it kind of takes everything that looks like this and makes it a whole picture. This is how they see. Every lens has a little piece in it. It makes a big mosaic, or like your television has all those little tiny dots that make a picture, and digital cameras do too. They do see colors. They see yellow, blue-green, blue, violet, and they use the ultraviolet. But there are some special colors. It's the mix of the yellow and the ultraviolet. They call it bee purple. And there's a lot of flowers that only show their nectar glands in ultraviolet. So if you don't have ultraviolet vision, you're not going to see it. And this is the ocelli. Do you see the 3 dots in the middle?
Yeah.
That's 3 eyes. So you see they have 2 compound eyes, and they have 3 ocelli. That gives them 5 eyes. Now these don't see a picture, like to look out and see you sitting there. They don't see that picture, but it sees other ways. This helps them. They triangulate where they live, where they are. They use the sun, they use the horizons, and they use home. So you know if you fly off 3 or 4 miles to look for food, or 2 or 3 miles, whatever it is, that sun's still not going to be in the same place. It's still moving. It's not going to be in the same place. So you got to be able to find your way home. Well, this helps them with their little internal GPS. It triangulates everything and they can get back home. They use ultraviolet lights with these, where the compound uses polarized. These use the ultraviolet that comes from the sun, which also penetrates the cloud cover. And this is the ultraviolet that they can see from the flowers. Now this is what they see under ultraviolet compared to us. See, we see this pretty purple and white flower. They see that. We see that yellow up top. They see this purple. This is top. This is bees. We're on that side. This is bees. Some of theirs, I think, is much prettier than ours. And some of ours is prettier than theirs. But you can see the color kind of what they see. And that's all. That's the ultraviolet. This is their mandible. This is located in the front. They use this for anything that needs gripping, squeezing, prying, chewing, anything like that. You take a sandwich. We're going to eat a sandwich like this because our mouths move like this. Well, if we have a sandwich like this and theirs move like this, they're not successful. So they have things this way, and they can chew this way. Take them off. They get wax, and they build their comb with it. They gather the propolis and stuff it in places they need to do to weatherproof their hives. They cut their own self out of their cells. They help the drones cut out of their cells. I don't know why drones need help, but drones need help to be cut out of their cells. They can cut bee bread out. They take food to the larva. They feed the queen. Anything that does like that. If they need to get in a place and the entrance isn't quite big enough, they'll use that to chew. Now, it's very sharp and they're strong, but they're not so strong for a lot of endurance. So it'll take quite a few of them to work on an area like chewing wood. You know, a little bit of time, because they're not powerhouses. Well, they're small. When they're not in use, though, they just tuck back under. Now, this is their proboscis. You'll see some people, they'll say, oh, look at their tongue. It's not really a tongue, and it's not one thing. It's made up of a few things. This is just an illustration of the head, so you can see where it is in relation, because that's up close. You see those cilia up top, you see the antenna, the compound eyes, where that mandible we were talking about, and then those pieces underneath is what makes the proboscis. There's stipes, paraglossa, labial palpus, and a glossa. Now, it's hairy or feathery. It's flexible. Those things come down around this glossa and kind of give it stability. It uses muscles to make suction to pull that nectar back up through, but it's very flexible. It laps and it picks stuff up. When it's not in use, it also, those pieces just lay back and it gets out of the way. So some of the things that they use them for, you see how she has it extended? It looks like one piece. I don't know if you can see it close, but at the end you can see that there's a few pieces. Now, she'll either gather the dew or the water from your sprinkler or whatever to take water back to the hive, because it's important they have to have water, not just honey. They gather the nectar from the flowers. If there's some overripe fruit that's their mandible can break through the skin, they'll gather the juice from it too. Over here, they're passing it back and forth because they have to dry it down, because nectar is so much water. Before it can be honey, they have to dry it down. And they'll start that process right away. They have a stomach that they use for their own food. They also have a crop. If you've heard that in chickens' crops, they call it a honey stomach. They have a separate one that they collect all their nectar in. Then they eject it back out. They give it to the other bee that's the worker, because she doesn't really ever have to come inside. She just works. She flies out, she gets the nectar, the pollen. She comes back, they unload the pollen from her, they take the nectar from her, and they'll feed her. See these down here? They'll feed her and give her substance and send her right back out to work. She don't get a break. That's how come they actually really fly themselves to death. But they'll pass this and blow bubbles and start the drying process, and they put all the good enzymes that honeybees have to make honey so healthy. Now this is the thorax. It's the middle. You see that funny part that looks like a sponge? I want you to know where this, we have some people that get confused because our legs are on the bottom, so they think that's the abdomen. But no, their legs are attached to their thorax. Everything that has to do with locomotion is in their thorax. Their wings are there. The flight muscles for their wings are there. Their legs are there. The muscles that move those are there. Everything is right there, and the thorax is right in the middle.
So basically it's like the engine area.
Pardon me?
It's like the engine area.
It is. Yep. Well, their brain kind of takes care of running it all. But that's the locomotion area. Now, this is their legs. They have 3 legs. Each bee has 3 legs. Each leg is different, but not all of them are the same on each bee. They all are jointed. They all have 6 segments. They have claws that can help them hang on tree bark, the side of their hive, your clothes if they get near you. They hang on texture. And they have soft foot pads that help them with smooth surfaces like glass. They can walk on glass because they have smooth surfaces that helps with traction. Now they all have an antenna cleaner, because if you don't keep your antenna clean and it's full of debris, you don't know what's happening around you. Remember, that's the part that senses everything. So if you don't keep it clean and you get it all full of junk and you just leave it that way, you can't tell what's happening. So they all have that. Now the worker, she's the only one that goes out, so she's the only one that needs to have pollen brushes and pollen presses. Actually, they have brushes, but the pollen basket and the pollen press. Now, their front leg cleans the front. Their middle leg cleans the thorax. Their back leg cleans the abdomen. Kind of pretty simple to see there. But the pollen press and the pollen basket belongs to the worker, because she's the only one that does the work. Here's up close of what an antenna. Nobody has a good picture. I had to go with illustrations. But you see that there's a spur, and they put that antenna in that notch, and it's got hairs on it, and that spur, and it holds it, and they can pull through, and they can clean that antenna. And over here is a pollen basket and a pollen press. You see between the pieces? That's where it presses. You see up above that how it's kind of flat and those stiff hairs are around? That's the basket. That holds all that pollen so she can get back. But look how loaded she is with pollen. When you see a bee that has these colors, it could be yellow, it could be red, it could be orange, that's her pollen that she's bringing back.
Cool.
Yeah, it is. Sometimes they're so full they can barely fly. Now, they have 2 wings on each side. Their front wing is larger than the hind wing. They have the ability to hook them together. This is what they look like unhooked. And over there is what they look like hooked. And down here's the hooks. One wing has a groove in it, and one wing has the little hooks. They hook them together, and that gives them stability in flying. They get higher, go further. And it makes them stable. Now, they use them for flight. They use them to cool the hive. Did you know it's hot? It's hot in our house, and we want to turn on fans and stuff. Well, all they have for fans is their wings. They'll bring in water, like a swamp cooler. If any of y'all lived out west, they'll bring in water. They'll fan. They cool down the hive that way. They'll come outside to alleviate some of that heat, and they'll pull that air inside or pull that hot air out. They use it to dry that nectar, because just blowing the bubbles isn't enough to dry the nectar. So when they put it into the honeycomb, into the cells, they'll continue to fan and dry it out till it gets dry enough, and they'll cap it. They also use it to spread the pheromones around, because that is how they know what's happening. The queen has a pheromone, and she uses that to control the hive. They have other glands I'll tell you about that they use different pheromones for different things. But this is their wings. That's what they use them for. Now, we have lungs. And that's how we breed. They do not. They have a tracheal system, but they have what they call spiracles. Now, y'all seen shows how dolphins and whales have a blowhole, and they'll come up and blow water out and take air in? Well, they have muscles that open and close those spiracles. And that's how they breathe. And it's all down the side. They can close, you'll see them sometimes, they fall in your bird bath or whatever. They can close them for short periods of time. But just like us, you got to try to get a breath, they'll open them and they can drown. So they can't keep them closed forever. But you'll see there's 2 in the thorax and there's 6 in the abdomen. And that same muscles that draw the air in pushes the air back out. Now, I know it's a little fuzzy. Can you see right here? See those that look like little dots? That's the spiracles on the bee. So they've got hair around them. But that is it. That's why we try to save them when they get in the water. They'll tuck up, if they get caught in the rain, they can tuck up under something and close their wings down and still let the rain run off of them. But big old raindrops and little bees, sometimes it's pretty bad mix. Now this big section, this is the abdomen, this big fat section at the back. It's armor plated because it's an exoskeleton, just like the thorax is. This is where their wax glands are, the spiracles that I told you about, their sting or stinger. It's really called a sting, but people call them a stinger. It's in the back. And inside of this is all their vital organs. Their digestive, their heart, their everything. Everything is inside that.
Is that a queen?
That one may be. I can't tell from the top. I mean, I can't see the top. Oh, yes, she is. Look at her wings. See how short her wings are? Good eye. Now, these wax glands, what you see is not actually the glands, but these are plates that when they're a little less than a week, they start getting a separation in them. And they reach a peak, and then they start diminishing. So by the time that they're old enough to go out to forage, they're completely closed again. But their peak days to the optimal, when they're open the most, to produce the most wax, is 12 to 18 days. The little glands are under there, and it secretes a liquid wax. And it sits in the little depressions under there, and it hardens into these scales. And then they'll take one of those spurs on their leg, pull that scale up, and they use those mandibles, and they form it and start building their house and make their honeycomb. So they are between plates 4 and 7. So they don't produce them their entire lives. They produce them when it's needed. But it's not as clear, but I've never actually been able to open a hive and see one myself, so I wanted you to see how it's produced.
So that's how they make beeswax.
That is the beeswax. Now beeswax is the fat. Yes, ma'am.
What type of bee can do that? Is it just like a certain bee, or can all?
Well, this is the honeybee. Now she's the only one I know about. I don't know about other bees. She's the only one that I've learned. I don't know. The wasps do paper. I'm not exactly sure. I think they pick up litter and chew it and make that. I don't know if any other bee makes wax. Does any other bee make wax?
Not in the quantity as the honeybee. The bumblebee makes a wax
But just for
for their whole.
yeah, and there's a solitary bee that makes a little. I don't know if she uses wax. She just makes a little pot. I think they call them a potter's bee. They make a little pot of honey, but it's just for their own. The honeybee is the only one that makes an excess. That's all they know to do is to plan for tomorrow. They don't even think. They don't even plan. They just do. They're programmed to do. So they make an excess. Pardon me?
There's a stingless bee in South America, which is the original honeybee,
And she makes a little bit, doesn't she?
and they produce wax.
Yeah.
Is that a worker bee that does that?
Yes. Only a worker bee. The queen has no reason to because she doesn't build. She's too busy laying eggs. She doesn't build in the drone. He doesn't. So I thought that was pretty cool. They're little tiny pieces that come out. You know how tiny a bee is. You see how tiny her abdomen would be. That's a lot of work to produce that wax over time. Now, I know that you were asking about, somebody was asking about the stinger and the venom sac and whatnot. This is what it looks like when it's been pulled out. See, the stinger part is up. The lower part of the abdomen that has the venom sac is still attached to the back. That other piece trailing is kind of intestinal tract, sorry, but that's the only picture I have. They have two serrated plates and the venom sac that make it, and it's barbed, so when it goes in us, it doesn't pull back out. They don't die with other insects, but they die when they do us. But now, the workers have it. The queens, hers are not barbed at all. She uses hers just to get rid of other queens because they might make multiple queens, and the first one out she's going to do, and she's going to get rid of all the other queens because there can only be one. Now the worker, she's not going to look at you and go, I need to sting you. She's only going to use it for defense. So if you don't give her a reason, she should not sting you. Most of the time when I get stung, it's because I haven't seen them on me, and I've run my hand across them, or my arms across them. And the drone, he doesn't have one. Now, it's a ovipositor for the queen. It's modified because the worker's not laying, because the queen is producing that pheromone. And the drone, he never was built to lay eggs, so he doesn't even have a stinger. These are the glands. Now I have some notes on these because Chappie helped me with these, so I don't mess them up. So they have a whole lot more. No, you can eat. I just told him that you helped me. They have a lot more glands than this, but some of them, it's not the stuff that you really need to know right now. I don't really need to know if you want to know these, but I'm going to tell you. The hypopharyngeal gland. It's on both sides of their head, and it comes down through tubes down by their mouth. This produces royal jelly, or some people call it bee milk. It's not. It's white, though. It's royal jelly. And I'm going to tell you, so I don't mess it up here. It's located in the head of the nurse bees. Now remember, bees have different jobs, different times, so there's only certain ages that they're nurse bees. These secrete royal jelly, and it's used to feed the larva along with pollen and nectar. Royal jelly is very high in protein, and if that's all that's fed to a fertilized larva, she'll develop into a queen. Now it's high in protein because to lay eggs, have good eggs, and lay strong, good colony, you got to have high protein. So the larvae eat a lot when they're developing. Those bees work pretty hard. The next one is the mandibular. Remember where the mandibles are? The mandibular gland is near that. Now, it produces a pheromone by the queen. She goes around and she marks everything. She spreads that pheromone all through her colony. That tells the rest of them that she's there, she's viable, she's still doing a good job. They don't need to replace her. They don't need to try to do something different. This is her domain. She lets them know that way. So it produces a pheromone used by the queen to keep the workers aware of her presence. It also produces a type of preservative that's mixed with the bee food that keeps it from spoiling. That's pretty cool.
It's on her feet too.
It's on her feet?
She has glands on her feet too.
I thought I'm learning something, sorry. I thought that it was produced there and she just spread it with her feet. So she has glands on her feet. What are they called?
Feet glands.
Feet glands. There you go, feet glands. Okay, I'm probably going to ruin this, and I'm sorry, because Chavnikov, is that close? It's located under the bee sting, and it produces a pheromone that alerts the other bees that there might be a danger, or there is. If somebody's causing a problem, and the bee has stung, this pheromone comes out that says to the rest of her sisters, we need to protect this hive. So everybody comes and they'll sting near that same place over and over. So if you got a big old bear and she gets him on the nose, it's more effective if they all come and get him on the nose than if everybody picks a paw or a back or whatever, because it's not going to affect him. But if they all come to the same place and sting, they'll make a better impact. Yes, sir.
Does that only come out when the stinger comes out?
Yes.
Okay.
I think so.
Alright.
I will find out for you.
Okay.
So, I don't think so. I don't know, but I'll find out. But we use smoke, and that masks that pheromone, because it masks a lot of pheromones when we use smoke. And that helps us keep safe. I'll ask Chappie in just a second. Please remember that question. All right. And then he told you about the Nasonoff gland. I'm going to tell you about it, but I want to show it to you too. But so let me tell you about the venom. Now that one comes out. That's the one that we saw attached to that stinger. That one comes out and it continues to pump the venom in. But I'm going to show you this Nasonoff because you may not see it with your eyes. You may not see it on here. Do you see this shining white right here?
Yeah.
That's that gland. When you work your bees, you're going to see, and when you go down to the hives, you're going to see a whole lot of bees are going to stick their hiney's up in the air, and they're going to fan their wings like crazy. Well, when they do that, and they bend the tip of their tail, they bend it down, it exposes that gland that lets that pheromone out. Now, this one is used by the bees to help other bees locate things they might need. They might need to find where the queen is. In case there's a swarm, you don't want bees all swarming off and not knowing where to gather back. So they all get a tighter clump. They might find a really good patch of flowers and they'll leave that. When foraging bees coming home, at the end of their life, they're not as astute as at the beginning, when they're first foraging because they're getting wore out. It helps, they smell that this is home. And it helps them do that to return home. But like I said, it's located in, and you are going to be able to see this because when we go down there, there's a bunch of them. You get in your hive, you'll always see fanning like that. They will fan to cool off, but they're not going to expose that gland necessarily. They still may stick their butts up, but they don't expose the gland. Or they may fan and they don't have their honeys up. That's just cooling things off. But let me see, because if y'all don't have questions besides yours, I'm done. But do you have questions? I'll answer you. Any of them? Oh, thank you. Is that like thank God she's done?